All right, so this problem is going to be kind of long, and we're going to find the derivative of the following functions, or this whole function right here. So the first thing that I'm going to do is I'm going to write everything with exponents instead of the square root sign. So I'm going to rewrite this. I'll get f of x is equal to x to the negative 3 plus x to the 1/2 plus parentheses x plus 1, x to the 1/2 again, plus 2. So we're going to need to do these parts, or these things in parts. We're going to need to use power rule a whole bunch, and then we're also going to be using product rule. So I'm going to go ahead and kind of segment this portion off. So I'm going to do here, this will be yellow, and then this is going to be green. And then this one right here, we're going to end up using our product rule. So I'm going to kind of leave it alone for now. Okay, so for these first parts, I'm going to have here that the derivative is going to be, so I'm going to take this exponent here and get negative 3x, and then I'm going to reduce this power by 1. So negative 3 minus 1 is negative 4. So the derivative for the first part is just going to be negative 3x to the negative 4. Then same idea for the second part right here. So I'm going to do 1/2 x and then reduce this by 1. So 1/2 minus 1 is negative 1/2. Okay, now for this other part, we're going to break this down using the product rule. So I'm going to let this part be the f and then this part be the g. Now technically, it's a little sloppy to be using the same letters, but hopefully it'll make enough sense. So I'm going to have here f is going to be equal to x plus 1, and then g is equal to x to the 1/2 plus 2. So I'm going to first figure out what the derivatives of those functions are using the product rule. So I have f prime here is going to be the derivative of x is just 1, and then the derivative of 1 is 0 because a constant has a derivative of 0. For g prime here, I'm going to take the exponent, multiply by the exponent, and then reduce the exponent by 1. So 1/2 minus 1 is negative 1/2. And then the derivative of a constant is 0. Okay, so now we're going to use this whole rule right here. What you'll notice is that these kind of go back and forth a little bit. So we're going to multiply these two together, and then we're going to multiply these two together. Okay, so here what I'm going to have, so I'm going to add plus, and then f times g prime, so x plus 1 times g prime, which is 1/2 x to the negative 1/2, plus, now I'm going to go the opposite way, so I'm going to have x to the 1/2 plus 2 times this one over here, times 1. Okay, so this is a huge amount of stuff, but we're going to simplify it a little bit farther. So this here is just going to become the same. And I'm going to go ahead and write the exponents the same for now, and then I'll simplify them later. Now this I'm going to use distributive property to try to figure out what this would be. So I'm going to have 1/2 times x to the negative 1/2. So this is x to the 1. So that's going to be 1/2 x to the 1/2. And then 1/2 x to the negative 1/2 times 1 is 1/2 x to the negative 1/2. And then this one is nice because I'm only multiplying by 1. So I'm going to have plus x to the 1/2 plus 2. Okay, so there's a whole bunch of stuff. You can see that there's some terms that we can combine. So we have 1 half x to the negative 1 half right here. And then we also have a 1 half x to the negative 1 half. So those are going to combine to be 1 half plus 1 half is going to just be 1. So I'm going to have x to the negative 1 half for those ones. And then here I have 1 half x to the 1 half plus x to the 1 half. And so 1 half plus 1 is going to be 3 halves x to the 1 half. And then these other portions here are going to just come down. If I want to write it with positive exponents only, that's going to translate to negative 3 over x to the 4th plus 1 over x to the 1 half plus 3 over 2 x to the 1 half in the numerator plus 2.